So suppose you have 3 points from your friend. What would you do to get S back? So the idea is like we want to take this point, okay? We know these 3 points, right? And we wanna somehow generate recover the polynomial back, okay? So this process is called interpolation. Okay, so we will learn how to do that. Okay, there are many ways you can do that. You can basically just write out the linear equations and use Gaussian elimination to do that. That would be fine, but it won't be that much fun. So we use another way. So the method that we learn is called the Lagrange interpolation. So let's see how it works. It's not that difficult. It's not difficult, and it's also related to stuff we learn in linear algebra a little bit. So that's why I like it. So let's do that. So the process that we do this is called evaluation. So evaluation is the process that you move from polynomial to points. Okay, interpolation is from points back to polynomial. Okay, so evaluation, interpolation. So how are we gonna do interpolation? Okay, so this is evaluations, polynomial to points. Let me see if I record and if you have points, you want to go back to the polynomial. It's called interpolation. So this is the example that I'll use. So suppose there's a polynomial over TF11 of degree 2 going through this point. I want to find Px. Okay. How am I going to do that? So let's look at the picture first. I'll go in steps. So and each step is not that hard. Okay, so you should be able to follow it. So this is 1. So this is 2, 7, and 4, 10. 4, 10, and 7, 3. Probably this. Okay, it's a polynomial degree 2. It's really hard to actually find a polynomial that look exactly like this. Okay, so I'm going to do something else. Okay, I'm going to do something much more easy, like really easier than this. So let's focus. Let's try to focus on this point first. And this point is still hard to work on. Let's think about this point. Okay, this is point 2, 1. I want to find a polynomial that. Okay, let's focus on the first guy. Let's try to find a polynomial that is 1 here and is 0 in these 2 locations. Okay, I want to find a polynomial that is 1 at 2 and is 0 at 4 and 0 at 7. Okay. The reason why I do this will become more clear later on, but let's try to come up with this polynomial. Is there a nice polynomial look like this? It's kind of hard, right? So let's go a little bit further into a simpler task. So suppose I want to find a polynomial that is 0 at these 2 points of degree 2. Can I find a polynomial degree 2 that is 0 at 4 and 0 at 7 and non-zero at other places? If I want a polynomial degree 1, suppose I want a polynomial degree 1 that is 0 at 4, what is it? So x minus 4 is 0 at 4, right? I also want this polynomial to be 0 at 7. So what should I do? So I can just multiply the whole thing with x minus 7. So this is a polynomial, right? what is the degree? It's a polynomial of degree 2. Okay? And it is 0 at 4 and 7. Okay? If you plot it, it would look like, I don't know, it would look like something like probably this. Probably this. I don't know, I guess it would look like this. Okay? It's the polynomial degree 2, right? So it's a parabola. So look like, or maybe it's the other way around, maybe it look like this. I don't know. Okay? One way or another, but you should think about it. Okay, now this is a polynomial that is 0 at this and this. But I don't know the value of this polynomial at 2, right? Okay, I'm halfway there. Okay. Now, can I find a polynomial that is also evaluate to 1 at 2 at this point? What should I do? So let's see. Suppose this is my polynomial. Let's call it polynomial g. So let's take a look at this value of g at 2. So I plug in g2. What is g2? So it should be 2 minus 4 times 2 minus 7. And that's, what is this? Minus 2 times minus 5. So it's 10. Okay? So I know that g at 2 is 10. Right? So how can I change this function so that it's 1 at this point? So right now it's here. It's this point, it's 10. So how can I make it 1? So I can just divide by 10, right? Right? I divide the whole thing by 10. So I get 1. Okay? But what exactly is 10? So 10 is this. So let me put it in there. 10 is 2 minus 4 and 2 minus 7. So I want this function to be 1 at 2, right? So I divide the value of the upper terms of the denominator here as well. So it cancels out, so you get 1. And it's also 0 at 4, and it's also 0 at 7. Okay? So this is a function that I like. Let me call it, I'm not going to call it g, I'm going to call it delta 1. Okay? What is delta 1? So delta 1 is a function that is 1. 1 as this, and 0 at these 2 points. Okay? Now, let's define what is, so I want to find delta 2. Okay? Can you guess what I should look at? So delta 2 is a function that, so let me use color green. It's 1 when it's 4, when x is 4, this is 1, and it's going to be 0 at 2 other points. Okay? So can I find delta 2? So let's follow the same step. It has to be 0 at 2 and 7, right? So it's going to be x minus 2, ฟังด้วยครับพี่ x minus 7, okay? So this is polynomial degree 2, okay? And it's 0 at 2 because you have one factor is x minus 2. It's 0 at 7 because you have x minus 7. But you want it to be 1 at 4, right? What should you do? So I divide the whole thing with what? Okay? So let's write out the whole polynomial. Okay? So this is like x minus 2, this will be x squared, and then minus 2 plus minus 7, so it's going to be minus 9x, and then plus 14. Okay? But we do everything modulo 11. Okay? So 14 is, you can modulo after this, but you can keep moduloing. Okay? So 14 is 3, right? And you want to divide by, this is 2, this is minus 3. Okay, so 2 minus 3 is minus 6. Okay, but we perform everything modulo 11. Okay, if you want to divide by minus 6, it's really hard. So minus 6 is 5, right? So it's going to be 5. You divide the whole thing by 5. But how you divide by 5? You multiply it by 9. Recall the table on the other page. You have a table, right? So the inverse of 5, so it's going to be 9 times x minus 9. Minus 9 is 2, right? So let me try to simplify my life. Okay, so you multiply the whole thing, you get 9x squared plus 18. 18 is 7x plus 27, right? 27 is 5. So this is like my alpha 2. Okay. If you plug in alpha 2, if you plug in 2 into it, what will you get? 5 plus 14. So let's plug in 2. So 5 plus 14 plus 9 times 4. That should be what is it? 55, right? Okay, so it's 0. Okay. If you plug in 4, you can see it's gonna be 1 modulo 11. Okay. So you can also work on this. So let me do it really quickly. So it's gonna be x squared minus 11x plus 28, but 28 is 6, right? Plus 6. This is 0. Oh, nice, right? 0. Minus 11 is 0. 6 over this is minus 2. This is minus 5 over 10. But what's the multiplicative inverse of 10? Is 10, right? So it's going to be 10 x squared plus 60. But 60 is what is 60? 60 is 5, right? Okay, more 11. So this is another component. Okay. I need to compute also delta 3. Okay. What is delta 3? Delta 3 is going to be a function that is 1 at this point and going to be 0 at these 2 points. Okay. So delta 3, the formula of delta 3x is going to be don't follow me because you have different points. You have to use. I'll let you do that, but let's see. Okay, so delta 3 is going to be 0 at these 2 points. So it's going to be x minus 2 times x minus 4. And it's going to be 1 here at 7. So it should be 7 minus 2 times 7 minus 4. And then you should simplify, and then you get another polynomial. Okay? Alright, so what happens if you have these 3 polynomials? I'll let you work on it, okay? But what do you get when you have these 3 polynomials? Okay? You can think of this, you want to have another polynomial that is 7 at this point, right? And 10 at this point, and 3 at this point, right? Think about this. If I multiply delta 1 with 7, what do I get? If you multiply delta 1 with 7, I will get some polynomial that would look like this. Okay? If I multiply delta 2 with 10, okay? I know that delta 2 is 1 at this point, right? So whenever I multiply with 10, it will reach this point. But it will remain 0 at these 2 points because previously it is 0. If I multiply with 10, 0 is going to be just 10, right? So I shouldn't use green, so I use red.
So if you multiply delta 1, I'll get this polynomial. If I multiply delta 2 with 10, I'll get a polynomial that probably look like this. Go through this. Okay. And if I multiply delta 3 with 7, I would probably get this. Okay. Now you can see if I add all of them up, okay, if I add all the polynomial up, I'll get a polynomial that is 7 at 2 because the other polynomial is 0 at this point. Okay. I also gonna get a polynomial that goes through 10 for 10 because the other two polynomial is 0 at this point. And I also get a polynomial that goes through 7, 3 at this point because the other polynomial goes to 0 at this, and then this is like go to 1 and multiply by 3, right? So my final polynomial is this. The goal that I want is this 7 times this plus 10 times delta 2x plus 3 times delta 3x. So this is my final polynomial of degree 2 that goes through the points. Okay? So that's the idea. So let's see how we actually did it. So the other one, okay, the other one, the other 2, the other 3. Now I combine them, okay? I know that the other one is 1 at 2, right? And 0 at everywhere else. No, not everywhere else. 0 at this at 4 and 7. So I multiply 7 and I multiply 10 and 3. And I have this polynomial. That's what I want. That's the final polynomial. Okay. If you think about this, the first polynomial, when you think about the value at 2, 4 and 7, the first polynomial is 1 and 0, 0, right? The second polynomial is 0, 1, 0. The third polynomial is 0, 0 and 1. And when you want a polynomial that is 7 at this point, at this coordinate, x coordinate, and 110 at this coordinate, and 3 at this coordinate, you can combine them linearly. The final polynomial is like a linear combination of these 3 polynomial, okay? And this 3 polynomial is like a basis, right? So 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, okay? And you want a final polynomial that is like 7, 10, and 3, right? So you multiply the first polynomial with 7, you multiply the other one with 3, and you get the function, okay? Okay, so let's work on your points. Okay, for the student who came late, you can take the points of the polynomial from your friend. Take 3 points, and then do the interpolation. Okay. Okay. So first of all, compute delta 1. So let me tell you again what are they. So delta 1. So work on your points. ทำของจุดของตัวเองนะครับ do the interpolation of your point. So suppose your point is x1, y1, x2, y2, x3, y3. Okay. So you want delta 1 to be 1 at x1 and 0 at x2 at x3. Right? So the delta 1 is gonna be x minus x1, x minus x2. Oh, sorry. You want 1 at x1, so it's gonna be x minus x2, x minus x. Okay. And you want it to be 1 at x1, so you divide this by x1 plus x2. So this is delta 1. So it looks like this. So you should plug in the x coordinate of your points to obtain x delta 1. So let me write you another delta 3. Delta 3 you want to be 0 at x1, 0 at x2, and 1 at x3, right? So delta 3 would look like x minus x1, x minus x2, and you want it to be 1 at x3, right? So you plug in x3 into the top expressions. So that would be delta 3, okay? You should figure out delta 2 yourself and do the calculations, okay? Don't cancel out minus. You make a mistake. So you have minus, turn it to some plus number, some positive number, and then do the divisions, okay? ทำเลยครับ work on the delta first, and then your polynomial, final polynomial will be delta 1 times y1 plus y2 times delta 2 plus y3 times delta 3. That's the final polynomial that you have.